All right, so we're going to piggyback on to tangents real quick to make a short video on the more tangent line properties video. You have your two properties at the top here. When you get two tangent lines that come to a common intersection, like AB and CB, both have an endpoint in common, that would be B, those two pieces are equal. Okay, so look at 10 and 11 real quickly. This video will not take long. To solve 10 for x, you will just take these two segments, CB and AB, and make them equal. That is all. That's all you'll do. Now, if you were to need to find PQ here, okay, make sure if you see a set of directions that says PQ, the process to find x is just like number 10 to the left, but you'll have to solve x and plug it in. Okay, so solving this would get me x equals 3. I just did it real quick. I end up having 6x equals 18, and then that gets you 3. To find PQ, we're just going to put 314 times 3 minus 13, so your final answer will be 29, not 3. Okay, so let's take this concept that we see is that when you see, so these two pieces on this picture are going to be equal. Okay, these two pieces that meet at C are going to be equal to each other, and these two pieces that meet at A are going to equal to each other. And if a circle is on the interior of a triangle or quadrilateral, this is called circumscribed. That means inside around the circle, then all sides are tangent. And that's what I just said, all sides are tangent. These two pieces are equal. These two red pieces are equal. These two blue pieces are equal. We can find the perimeter. So we would just add this all together plus all of this plus all of this to get the perimeter. So let's take a look at this. This is an easy example. So number 13 would be an easy example. So since both these pieces meet at E, they have to be equal. So there's why this side is 16. So both these segments meet at D, and they have to be equal. And both these segments meet at F, and they have to be equal. So to find the perimeter, I'm adding all those numbers up. So if you do that on your calculator, 2 16s, 2 11s, and 2 9.5s, you should get 73 as the perimeter. Remember, perimeter is adding up all outside edges. So let's look at a more challenging part. Okay, so the reason why this is challenging is because let's look at P first. So if I look at P, these two segments must be the same. Okay, well, if I know this is 37.5, now I know this piece has to be 23 because it meets at P and the other piece is 23. And now I have to find this portion of the 37.5. So that is 37.5 minus 23, and you should get 14.5 for this little piece. What does that mean? Is that this portion is 14.5. Okay, so let's move on to the next corner, R. This part is 27.1. This part has to be 27.1. So now it's just a little plus little equals big. This is the first chapter of geometry, is this segment addition postulate. This is basically what I'm doing. If this is 27.1 and the whole thing is 52.5, it's 52.5 minus 27.1. And I'll pick a new color. This portion has to be 25.4 because that is 42.5 minus 27.1. Now I know this portion is 25.4, and we have a ton of numbers to add together. You can use the 37.5 and the 52.5 as two of your numbers because you already have those two sides. Okay, so this whole side here would just be a sum of the 23 and the 25.4. And this whole side here would be a sum of the 14.5 and 27.1. So adding this number, these two numbers make that side, and these two numbers make that side. Adding all that up, you should actually get a perimeter of 180 even. And that is the end of the video for your second tangent video. It was pretty short and sweet. I just didn't want to add it on to the other one to make it too long.